the denominator, and that solves the equation. Here's what it would look like. I would take both sides and multiply by 17, and I would write down 17 tangent of 54 is x. And that's how I'm going to get some decimal. Okay? Now, one of the things that I need you guys to make sure of is, do you know how to check what mode your calculator is in? On the calculator, on the screen that you guys have, you should have some thing that on the top part where it says DEG, like the top right. Does everybody say DEG on there? Nope. It stands for degrees. If you look, all right, everybody see where it says Texas Instruments on the screen here? Right underneath the TS, there should be 3 letters. It should say DEG. Everybody see that?
No.
Yeah.
Yes, we're seeing these blonde.
Yeah. Everybody not find it?
Which one do you want?
DEG. Degrees.
Right
It says for
there.
degrees.
Well,
Rad is radian measure, and that's, you'll probably never use your calculator when you're in radian measure. Radian measure, it's a default a lot of times on graphing calculators. I don't think anybody in here is using the graphing calculator. Yes, ma'am? What's that? Right here where it says, underneath the TS, it says DEG. So you're fine. Okay, you're fine. You guys have calculators? You need to get a new one, not probably. Okay, cool. So what happens is, no matter what, in this class, you always have to make sure that your calculator is in that degree mode. Sometimes if you drop these calculators, especially, not so much in this class as much, but I know like my Algebra 2 kids, we'll actually do stuff in degree mode, when we're solving right triangles. And if they drop their calculator or the battery dies or something like that, it defaults itself back to a radian measure. You could get really messed up answers by mistake. So in mine, or if some of you guys, if you hit mode, you'll come up with options. Mine's in radian, so before I do anything here, I gotta make sure mine's in degree. Then I just back out. So one of the, like we were saying, one of the major reasons that I ask that you guys always write down what you're going to put in your calculator before you use the calculator. And so that way we can always tell whether or not you know what you're doing. Because it is so easy to do this quickly and make a mistake and we won't be able to understand what you screwed up. Whereas you can accidentally take, if you type in the calculator 17 tangent 54, you just do this and hit enter, you get a decimal. Okay. Now, my requirement for you guys is to always round your decimals to the 100th, 2 decimal places. Okay. So if I'm looking at this, if I'm looking to round something to the 100th, oops, if I'm rounding to the 100th, I always look at the third number. Is that third number 5 or bigger?
Yes.
Which means I move the next one up a digit. So what's the next one from 39?
40.
40. So my answer then would be 23.4. Now, I want you to see something real quick. If I type in, let's say you wrote down 17 tangent 54, but let's say you accidentally typed 17 cosine 54 just by mistake and you hit the wrong button. And you wrote down 9.99. If you write down 9.99 for your answer, I don't know what you did. I have no idea. But if you write down this always tells me you know what you're doing. Okay? That always tells me you know what you're doing. But if you accidentally type something wrong in the calculator, it's easy for us to figure out where you went wrong. Whether you accidentally hit cosine, or you accidentally hit 52 instead of 54, or you hit 12 instead of 17. There's so many numbers in this unit that it's very, very easy to accidentally write something down incorrectly. Okay? Also, if you don't have the calculator on you, and you don't have it set up right now, if you forgot it, or you're waiting for one to be ordered, you can do all of the work except press the button at the end. Okay? Be careful if you use your phone. You use your phone probably defaults to radian measure. It's not gonna give you the right answer. You'd have to figure out how to switch it into degree mode. I know there's apps and things like that that'll do that, but everybody's stuff is a little bit different, okay? So our requirement, before you type anything in a calculator, before you do that, you always have to show us what you're going to do before you press the button. Does that seem fair? Think of it as a safety net for you, okay? I want you to think of it as a safety net because it will help determine whether or not you know what you're doing, all right? Not too bad if the variable's on the bottom, or excuse me, if the variable's on the top. So, remember, so if we have trig, oop, that's dead.
What is that?
That's close enough. No problem, please. Thank you, sir. So, if you have some trig of some angle is x over some number. This is a generic way of writing this out. This value of trig means it could be sine, cosine, or tangent. It doesn't matter. It's one of those. The x is the variable in the numerator. Could be an opposite, could be adjacent, could be an opposite. If it looks like that, you will always have the following step for a solution. Whatever the number is in the denominator, times your trig of theta, which is that angle they give you, will equal x. That's how you solve that one. That's the easy one. Because all you're doing is just undoing division. Okay? Remember, these ratios, these fractions, are just crummy decimals. These are all just crummy decimals. Back in the day, you probably remember this, the trig tables.
I have one at home.
I think our textbook actually has trig tables.
Does it?
Yeah, it's got a couple of pages of trig tables. We actually used to have to figure out what the, we would,
Sine, cosine, tangent.
yeah, you'd list them out, you'd figure them through, you would learn how to guesstimate where things are gonna wind out. You wind up how to be able to do all that stuff, so. Excuse me. So far, so good? Okay, let's look at the other method. The other method then. The other method is when you have x in the denominator. Now, what I want you guys to think of is in your calculator, if you just type cosine of 55, do you agree that you get just some crummy decimal?
Yes.
Okay. So what I want you to think of is this cosine of 55 is just a different way of writing down 0.573576436 and so on. I don't want to write all that junk down. I'm just going to leave it as the cosine of something. Okay. Now, these trig values, these trigonometric functions, sine, cosine, tangent, they are the equivalencies of some number divided by some other number. It's just a fraction. Remember, fractions are decimals. We just write them out, and they're cleaner when you write them out as fractions. The cosine or the sine or the tangent is just another way to represent a fraction. So if it's another way to represent a fraction, do I change it at all by doing that? No. So now I want you to remember what we did with similar triangles, similar figures. Remember when we did this, 2/4 equaled 1/2? Remember that? We could cross multiply, or let me write it out with a different number here. Let's say 3/6. Now, remember when we changed them on the diagonal? Did the ratio change? Or was it still true? It was still true. So if I flip-flop the 2 and the 3, I get 2/6, oops, is 1/3. Is that true or false?
True.
It's true. Because the properties, like we were saying, like go with cross multiply. So what happens is, if you have this cosine, was it 55 over 1? What did we say it equaled? It was something over x?
Yeah.
Was it 14? Okay. Now, whenever I have that in a denominator, all I'm going to do, not so, in essence, yes, we are going to cross multiply, but I'm going to make it an easier step. All I did here was flip them, didn't I?
So all you have to do is just.
Yeah. So then that means that x, 14 over the cosine of 55. Yeah, hit the button. That's it. Because what happens is, since you've got, these are just proportions. Proportions are ratios that are equal to each other. Since ratios are equal to each other, you can flip them on diagonals. And we did that back in chapter 5, right? 6, 5, 6, 6, 6,
7.
12, I don't know. So what happens then is that you get this generic idea that I can solve for that value. Whenever my value is in the denominator, I do this step every single time. I just flip them on the diagonal. That's it. It'll always work. Whiskey, like you were saying, isn't it like cross multiplying? Yeah, because you can multiply both sides by x, and then I'd have to divide it by the cosine of 55 to get it back to here. It's just a quicker way, instead of having to show those 3 steps to get to it. Knowing that you can do the exchange-o on the diagonal, because this is a proportion, because you're using those rules. Since you're using those rules, you don't have to show all that work. Okay? Yeah, you're not wrong. Not wrong at all. All right. So if you type that in your calculator, remember, you guys have a fraction bar. You can use the fraction bar. Take 14 over the cosine of 55 and hit enter. You can use the fraction bar. Or if you do it the other way, if you just take 14 divided by cosine of 55 and hit enter, you get the same thing. The reason that works is because there's nothing else in the numerator. It's just that 14. You're not adding anything, you're not subtracting, you're not doing any other stuff. Okay? It quite literally is one step. That's it. This is just one step. Right? Now, if I rounded this, 24.408, what do you round that to?
21 for 41.
Very good. And there's your answer. Okay? There's your answer. So again, if you have some trig value is some number divided by x, to solve for x here, all we're going to do is exchange-o, change-o on the diagonal. Exchange-o, change-o. And that's it. It seems like it should be a lot more complicated than it is. But that's all you have to do, because it is quite literally, ladies and gentlemen, a one-step algebra problem. That just looks really weird. Okay, that's it. All right, not terrible. All right. Well, let's do this. You guys have your ratios written out right now on this one. Take a few minutes, press the buttons, make sure you get the right answers. We'll check them. All right. Yeah.
What you gonna do?